Hey everyone, and welcome. We hear all the time about how AI is making science faster. But today, we're talking about something way bigger. We're going to dive into how AI isn't just accelerating discovery, it's making things possible that, until right now, were basically impossible. All right, let's get into it.
I mean, that's such a powerful way to think about it, right? Just like the microscope suddenly showed us this entire hidden world of tiny organisms, and the telescope opened up the cosmos, AI is doing something similar. It's giving us a brand new way of seeing, letting us understand patterns and complexities that were just, well, completely invisible to us before.
So this is the absolute core idea we're going to be exploring. For a long time, we thought of AI as an accelerator, a tool to crunch data faster. But the real revolution, the thing that's happening right now, is AI as an enabler. It's not just helping us run the same old race faster, it's opening up completely new races we never even knew we could run.
Okay, so to really get how this is all happening, here's a quick roadmap of where we're headed. We'll kick things off by looking at three huge barriers that have always held science back. Then we're going to see how AI is just shattering each one of them with some amazing real-world examples. And then we'll wrap up by talking about what this all means for the future of discovery itself.
You can think of every great tool in science as a key that unlocks a door. Well, today, we're looking at three of the most stubborn, most fundamental locked doors that have blocked scientists for centuries. And these are the barriers that AI is finally starting to pry open.
So here they are. First, you've got the barrier of just pure scale and complexity. These are problems with so many possible answers, you could never, ever check them all. Second, there's pattern and noise, where the answer you need is like a tiny whisper in the middle of a data hurricane. And third, a barrier that's a little closer to home, our own minds, our biases, our intuitions, and the limits of our creativity. These three challenges are going to be our guide.
Let's tackle that first barrier, impossible scale. Seriously, imagine trying to find one specific marked grain of sand on every single beach on Earth. It's just not possible, right? Well, some scientific problems are exactly like that. The number of possibilities is so huge that it's physically impossible for humans to even begin to explore.
For half a century, one of these grand challenges was protein folding. See, what a protein does is all down to its 3D shape. But trying to predict that shape was a nightmare. Why? Because the number of ways even one protein could fold is, well, it's a number so large it's bigger than the number of atoms in the known universe. No computer could ever brute force that.
And then AlphaFold happened. Instead of trying every possibility, it learned the rules of physics that govern folding. And the result? Just look at that number. It predicted the structures of over 200 million proteins, basically almost every known protein to science. Work that would have taken generations upon generations, done. That's not just making things faster, that's a whole new ballgame.
Let's keep going with this idea of scale because it just builds. Right now, we are facing a massive crisis with antibiotic resistance. And the problem is, finding a new antibiotic is another one of these insane needle in a haystack problems. I mean, how would you even start to test over 100 million different molecules in a lab? The short answer is you wouldn't. It would take way too much time and money. To really see the difference, just look at what a team at MIT did. They trained an AI to recognize what an antibiotic looks like at a molecular level. Then, they just let it loose on a digital library of over 100 million compounds. And what would have taken years in the lab, the AI did in a few days. And what it found was this molecule, helicin. But here's the kicker. The real breakthrough wasn't just finding a molecule. It was finding one that works in a completely new way that bacteria hadn't seen before. That means it's effective against some of the most dangerous superbugs out there. The AI didn't just find a needle in the haystack, it found a type of needle we didn't even know existed.
All right, let's move on to our second barrier, pattern and noise. With these problems, the issue isn't the number of possibilities, it's that the data is just a total mess. The signal you're desperately looking for is there, but it's buried under so much noise. It's like trying to hear a pin drop during a sold-out rock concert.
Take the LIGO Observatory, which listens for gravitational waves from colliding black holes. The ripples in spacetime it's trying to detect are, get this, 1/10,000th the width of a single proton. I mean, that is an unbelievably small measurement. At that scale, everything is noise. Tiny earthquakes, vibrations, even the quantum jitters of the laser itself.
So how in the world did AI help with that? Well,
Using reinforcement learning, it actually taught itself how to actively quiet the detector's mirrors to cancel out all that background noise in real time. And this wasn't a small improvement. It made the detector up to 100 times quieter. That pushed LEGO into a whole new level of sensitivity, allowing it to hear cosmic events that were totally drowned out before.
Another amazing example is the very first picture of a black hole. The data they collected to make that image was super sparse, full of huge gaps. Think of it like trying to figure out what a giant complex mural looks like, but you can only see it through a dozen tiny pinholes scattered across a wall. That was the challenge. To solve this puzzle, scientists built an AI named Primo. They fed it over 30,000 simulations of what black holes are supposed to look like based on our understanding of physics. So the AI developed a kind of intuition. And it used that intuition to intelligently fill in the blanks from the real data. The result was a stunningly sharper image, letting us test Einstein's theories with incredible precision. The AI literally saw the picture that was hidden in all that noise. And that brings us to our third and final barrier. And honestly, this is the most mind-bending part of the story. This is where AI overcomes the limits of our own human bias and intuition by basically becoming the scientist itself. We're moving from AI as just a tool to AI as the one actually making the discovery. And look, this is not science fiction. It's already happening. It really kicked off back in 2009 with a robot scientist named Adam. It was the first machine to form its own hypothesis, run its own experiments, and discover genuinely new scientific knowledge. Then came Eve for drug discovery. And today, this whole idea has evolved into what we call self-driving labs. So what is a self-driving lab? Well, think of it as a totally automated loop. An AI brain comes up with an experiment, robotic arms carry it out, mixing the chemicals or whatever it needs to do. The results are then fed straight back into the AI brain, which learns from it, and then decides the smartest next experiment to run. And this loop just goes on and on 24/7, exploring ideas way faster and more efficiently than any human team ever could. Okay, so what does all this mean when you put it together? AlphaFold, Halcyon, LIGO, these self-driving labs, these aren't just one-off cool stories. They're all signals that we are stepping into a brand new age of science, one that's going to totally redefine what it even means to be a scientist. But here's the key thing to remember. This doesn't make human scientists obsolete. Not at all. In fact, it elevates them. Instead of spending all their time doing tedious lab work or sifting through data, the human's role shifts. They become the high-level strategist, the one who asks the big imaginative questions and then points their AI collaborator at the next frontier. We get to focus on the why, and the AI takes care of the how. Now, of course, this kind of incredible power comes with some pretty big new questions we have to wrestle with. There's the black box problem, right? If an AI gives us an answer, but we can't fully understand its reasoning, how much should we trust it? There's also the risk that we'll start to favor only the types of problems AI is good at solving. And we have to be really careful that the AI, which learns from our data, doesn't just end up learning and amplifying our own existing biases and blind spots. And that leaves us with the defining question for this entire new era of science. As these amazing AI systems start to unlock the deepest secrets of the universe, from how life works to the very nature of the cosmos, what is the next great frontier for human curiosity? What is our new role in that journey? That's the exciting question we all get to figure out together. Thanks for joining me.